Okay, let's do a left-tailed example. So in this problem, a biologist wants to test if sunflowers treated with vinca minor extract result in lower height than the standard 15.7 centimeter average height for sunflowers with a standard deviation of 2 centimeters. So these two here, these are population terms. We want to do this hypothesis test at a level of significance of 0.05. This is arbitrarily set when we decide this. There's nothing, this is not etched in stone. 0.05 is not etched in stone or anything. We're just doing our hypothesis test at a level of significance of 0.05. So we start with a sample of 50 plants that are treated, and in that sample of 50, we get an average height of 15.4 centimeters. So what are we trying to do in this problem? Well, we're trying to show, even though this has come out to be a value that's lower than 15.7 centimeters, we haven't really statistically shown that this 15.4 centimeters, that these plants have a different population mean than 15.7 centimeters by a large enough margin for us to be convinced. And so we're trying to do this analysis at a level of significance of 0.05. So is this an indication that the treatment reduces the height of the plants? Well, let's see. We'll start out with our hypothesis test as usual, with a null hypothesis and an alternate hypothesis. So for our null hypothesis, like all our null hypothesis, we always start out with some mean value equal to something. And the value that we're looking at here is 15.7. So our alternate hypothesis is, we want to ask, is our mean height lower, smaller, less than 15.7? Okay. So let's do now step 2, our test stat. Okay, now this is a one mean problem. So we're looking at one mean. There's only one value here. One mean problem where the standard deviation is known. That's the only type of problem we've learned how to deal with right now. We're going to learn how to deal with situations where the standard deviation for the population is not known soon in the coming videos. But right now, this is all we could deal with. So this means we're going to use the z term here for our test stat, and it's going to be our x bar minus mu over sigma over square root of n. So in this case, x bar is our sample mean, and our sample mean is 15.4. We subtract that from our population, 15.7, divide this by the population standard deviation of 2 over the square root of our sample size, which is 50. Okay, calculate that. I get a value of minus 1.06. Okay, let's set this up now as, let's check our critical case. Find our critical region. All right, so this problem here. We're looking for a critical region over here, and our alpha is 0.05. So to find our critical z value associated with that area of 0.05, we can go to the tables and figure it out, or we can just come back up here and we can look at these values that I have written down for the typical values. For 0.05, z critical is minus 1.65. So the value of the z is minus 1.65. All right, popping back down to my examples here. So my Z crit here is equal to minus 1.65. So let's write that over here. Z crit equals minus 1.65. All right, so now I'm going to take my minus 1.06 and see where it falls in this plot. And minus 1.06 is here somewhere. Because recall, this is 0. The mean in the standard deviation is 0. The mean in the standard normal curve is 0. Standard deviation of the standard normal curve is 1. So this is just a little over, our test value is a little over 1 standard deviation to the left of the mean, but it falls here to the right. So since ZT is to the right of Z crit in a left-tailed test, essentially this is falling outside of the critical region. It's in this area, it's in the area here in the white area somewhere. It's not falling in the critical region. We do not reject our null hypothesis. So we do not reject our null hypothesis. So I can make a concluding remark here. We'll just call this 4. So we conclude that at we'll put an alpha level of significance equals 0.05, I'm pretty sure it was, wasn't it? Yeah, 0.05. There is not enough evidence to reject null hypothesis and so there's not enough evidence to indicate that the treatment with Vica minor, the extract, results in lower plant height. And that's pretty much all we can say about that.